Hey everyone, and welcome back to the channel. Today we are tackling a classic interview question, merge overlapping intervals, problem number 56. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. In this problem, we are given an array of intervals where each interval is represented as a pair of start and end times, indicating a time period, and our task is to merge all overlapping intervals and return a new array containing only the non-overlapping intervals that cover all the intervals in the input. Let's look at an example to make this crystal clear. In example 1, interval 1 starts at 1 and ends at 3. Interval 2 starts at 2 and ends at 6. Interval 3 starts at 8 and ends at 10. And finally, interval 4 starts at 15 and ends at 18. And we can see that intervals 1 and 2 overlap because interval 2 starts even before interval 1 ends. That is, starting time 2 in second interval is less than ending time 3 in first one. So, we merge the two intervals and get the new merged interval from 1 to 6. Next, we see this new interval doesn't overlap with interval 3 and interval 3 doesn't overlap with interval 4. So, our final list after merging all overlapping intervals would be following. Now let's look at example 2. It is a simpler one. Here intervals 1 to 4 and 4 to 5 touch at time 4, even though they don't strictly overlap in the sense of one starting before the other ends. They are contiguous and can be merged, and merging the two intervals gives new intervals starting with 1 and ending with 5. Now let's jump into the solution space. When we are working with the intervals, it is almost always a good idea to visualize them. So, we first draw the number line from 0 to 20, as that would cover all the intervals here. And then we plot their start and end time on this line for the intervals 1, 2, 3 and 4. And now, immediately we notice that interval 1 from 1 to 3 and interval 2 from 2 to 6 are clearly overlapping. And here visually, we see the order in the intervals. But programmatically, we should sort the intervals, say by their start time. Why? Because without sorting, we are stuck with the naive approach of comparing every interval with every other, which we briefly touched upon in our meeting rooms problem video. There, we saw 6 different ways two intervals A and B can have relation between them. But if we sort them first, we can process them in order, just looking at the adjacent intervals. For example, here we see interval 3 doesn't overlap with interval 2. Then we know for sure that all the intervals on the right of interval 3 won't overlap with the interval 2 anyways. And this is the key, that any intervals that could possibly overlap will appear adjacent to each other in the sorted list. So let's apply this. The first step is to sort the intervals by their start time. In this example, the intervals list is already sorted. So we go to the next step, which is to create the empty list to hold our final result. Let's call it merged. Now we start merging by going through the sorted list, picking one interval at a time. And for the first interval, since there is nothing before it to compare with, we can add it directly to our merge list to get things started. Now we process the rest of the sorted list, starting with interval from 2 to 6. We need to check if it overlaps with the last interval in our merge list, which is currently from 1 to 3. And the answer is yes here, because the start of the interval 2 is less than or equal to the end of the last merge interval 3. And because they overlap, we merge them by updating the end of the last interval in the merge list to be maximum of the current end, which is 3, and current interval's end, which is 6. So the new end is now 6, and the last merge interval is now from 1 to 6. Next, we move to interval from 8 to 10 and we check, does it overlap with the last interval in merged And the answer is no, because 8 is greater than 6. And since there is no overlap, we simply add this interval as a new separate interval to our list. And finally, we process the interval from 15 to 18, and it doesn't overlap as well because the starting time 15 is greater than the end time 10, and hence we add it to the list as well. And now, since we have processed all the intervals, we are done, and our merge list contains this final non-overlapping result. Now, the time complexity of this approach is O of n log n, which is dominated by the initial sorting step. Later, we go through this sorted list of intervals to merge the intervals. That takes O of n time. So, the overall time complexity is O of n log n. And the space complexity is O of n to store the merged list, or O of 1 if you don't count the output array. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on the left and Python on right. First, we sort the intervals array based on their start times. In Java, we use sort method with a lambda comparator, and in Python, we use a sort method with a key lambda. We then initialize an empty merged list and add the very first interval from our sorted list to it. This is our starting point for merging. Now, we loop through the rest of the intervals, starting from the second one at index 1. And inside the loop, we get the current interval that we are examining and the last interval from the merge list. And we check if the start time of the current interval is less than or equal to the end time of the last interval. If it is, then there is an overlap, and we merge the two intervals by updating the end time of the last interval to be the maximum of its current end time and current interval's end time. This effectively extends the last interval to cover the current one. Else, if there is no overlap, it means the current interval starts after the last interval ends. So, we simply add the current interval as a new distinct interval to the merge list. And after the loop finishes, the merge list contains all non-overlapping intervals. In Java, we convert this array list to an array before returning, while in Python, we simply return the merge list. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.